Hey everyone, thank you to everyone tuning in online. Again, my name is Emmett, one of the co-organizers of Flutter Atlanta. Today, super excited to be introducing Cardin, one of our long-standing members. He's going to be talking about testing. Without further ado, take it over, Cardin.
Thanks, Emmett. Hello everyone, Flutter Atlanta, and everyone watching online. My name is Cardin Menkemeller. I'm going to be talking today about testing your Flutter app. Some best practices for ways to do it quickly and efficiently as well. I did make this presentation public. If you want to check out the QR code, we'll also post it online afterwards as well. So a little bit about me. I've been using Flutter since 2018. I got on just after the first public release, after the first official launch. I'm a former Disney cast member. I was an industrial engineer for Disney, doing Walt Disney World and Disney Cruise Line for several years. I'm a big fan of the world travels. I've been to 25 plus countries from around the world. Favorites include Iceland, France, and South Africa so far. And I'm a big theme park enthusiast. When I'm not programming or working my normal 9-to-5 job, you can find me at a local theme park usually, or traveling around the country visiting theme parks. My wife and I are still pretty new to the Atlanta area. We moved here almost 3 years ago, 2.5 years ago. And when we moved here, we actually ended up in a small one-bedroom apartment, which if you guys have ever lived in there, it's super fun living with your spouse in a small, tiny space. And what I noticed is we ended up getting a lot of clutter because we came from a house, a full house, came down into a small one-bedroom apartment. It was rough. But now, for the past 2 years, we ended up buying a house here in Atlanta. I have a photo here, you can see. This is us. It looks a little bigger. I did a little upward shot, so it looks like kind of mansion-like, but I promise it's not huge. But one thing I noticed is our house seems to be more tidy more frequently, which confused me because we came from like a small space, and I expected more of a mess in a bigger spot. And I tried to figure out why that was. And here's what I think happened. I think that we have more people come over, and therefore we try to impress people, right? My wife has a group of girls that comes over every Monday night, and every time it's like half an hour till they come over, we're rushing around, like cleaning up the house. I'm sure you guys have the same things if you have like parents coming over or whatever, right? And then we also have, one of the things we decided when we got a big house was we want to have people help us clean the house. So we have a cleaner that comes every couple weeks. And for some reason we decided we can't embarrass ourselves in front of the cleaner. So before the cleaner gets there, we also clean the house, right? So what I'm trying to say in this case is, this is kind of like testing. People often ask me, like, why should I write tests? This is why. It takes a lot of energy, but it's really beneficial for the aftermath, keeping your space clean, keeping it tidy. One of the reasons that things get untidy in the first place is a term you guys might have heard in science, entropy. You guys ever remember that? Was anyone else forced to take thermodynamics in high school or college? Maybe just me? Okay. So if you remember any of that, entropy is like a measurement of randomness, right? In coding, we call this software rot, right? The idea that once you write code, your code starts to deteriorate over time, either due to, well, in our case in Flutter, packages, get upgraded. Flutter itself changes frequently, right? So your code will eventually deteriorate, and we want to try and prevent that. And one of those ways is by using tests. The second reason why you should test is because you're human and you make mistakes, right? Like I know me when I program, even though I like to say I'm infallible, I make huge mistakes, and tests help me catch that. But maybe you're not like me. Maybe you are a perfect coder, Emmett. So in that case, tests help your coworkers are human, right? And they make mistakes, and you want to catch those people who are helping you in your project, right? Then reason number 3, and the reason I think I've become a better coder is via testing. Testing makes you write code more efficiently, makes you think about what you're actually doing, is it best practices, and therefore you'll have tests that support that. All right, so let's get into Flutter specifics now. Let's talk about the different types of tests that Flutter have. First types of tests, really basic unit tests. Right? This is where you're starting to test logic. You're looking at functions, methods, specific classes. Really, really basic stuff. You're not dealing with any UI in this case. The next step up, a little bit of UI, what they call widget tests. So this stuff is when, widget tests are when you need to verify any kind of interactivity, any visuals, that kind of stuff, okay? You also get a fun new parameter in your test. So if I go back briefly to unit tests, you'll see I've got my entry point here where it says main on line 9, and I can dive directly, I'm sorry, line 10 I got my test, and I dive directly into the test from there. Here in widget tests, we actually get a nice new parameter called a widget tester, which helps us implement like a really basic environment where we can render a UI, but without having to do a full-blown UI system, okay? And finally, integration tests, which we're not going to be diving into tonight. These are a lot broader. This is where you're testing full-blown pieces of your app, partial implementations, testing flows, stuff like that. But this does bring me to a fun part. This is going to be our app for tonight that we're playing around with. I dove into the public Pokemon API, and we have the Flutter Atlanta app we're going to be playing around with a little bit as I show you guys how to write some tests. Any questions so far? Different types of tests? Pretty straightforward, right?
That's great.
Cool. I'm excited. So I want to talk a little bit, well, let me show you the app real quick, and then we'll talk a little bit about more what we're going to be doing. It's just 2 screens, pretty simple. I've got this home screen that lists out the first 151 Pokemon, and I can tap any of these Pokemon, and well, first I get a picture, and I get the name, and I can tap any of these, and it will pull up a little Poke Detail screen with some more photos and some basic information about that specific Pokemon. Really basic, super simple. I can go back, that's it. Yeah. Let's talk a little bit about testing fast and efficient. So that's my goal for tonight. Everyone knows about tests. Everyone knows tests are an option, but a lot of people don't take the time to write them because it's time consuming, you're trying to push out a product. So I'm gonna hopefully give you some tools and some details that will give you the knowledge necessary to push out tests quickly, efficiently, so your product is maintainable and sustainable. So first thing I want to talk about is dependency injection, right? Super scary word. Me coming from outside of the software world, I've never heard of this before. What the heck does dependency injection mean? In terms of testing, I think about it as substitution, okay? This is how my brain works. Do you guys remember in elementary school when your main teacher might leave for the day or be sick or whatever, or on vacation? You guys would have movie day. It was like the best time ever, right? Mm-hmm. What was really cool about that is you don't need a full-blown teacher to come in and have a movie day. Usually they'd bring in a substitute, right? So something similar we can do when we're doing tests, dependency injection, is this form of substitution. So I wrote this little example. I've got a class here that's called Watch a Movie, and the only method in this class is called Start the Movie. And I've got this teacher named Mrs. Smith who plays the movie. But Mrs. Smith is a rock star. Check out all the stuff she can do. She's a homeroom teacher, so she teaches history, math, she grades homework. If I scroll down, she teaches sociology, she teaches Arabic. I mean, she is just a total beast of a teacher. I don't know how she does it on a $30,000 paycheck, right? But on movie day, I don't need this teacher. I don't need someone who knows how to do all this. I need someone to come in and press play. That's all I need, right? So what I can do for movie day, I can create a nice substitute teacher. Extends my teacher class. and she can play the movie. I'm going to override my play the movie method and go from there. Super simple. In terms of testing, sometimes we call these mocks, right? So a little bit later, you're going to see what we're doing with mock teacher or mocking classes. Okay, just keep that in mind, because it's going to be really important later. Oh, and then when we go to play the movie, the injection part comes in. We use that substitute teacher, inject that into our method or class that's using our initial teacher, and we can use our substitute teacher in that case. Cool. Let's talk about some testing tools real quick before we dive into some more code. So these are the few things we're going to be using today. One, we're going to talk quickly about how to run tests in Flutter, super easy command-wise. And then a few packages we're going to use throughout the day, or throughout the rest of the presentation. Block tests. So I use block in this presentation, but this goes for any state management you use. So GetX has its own testing package. I'm sure there are some for any other state management you want to use. Mocktail, or if you've heard of Mockito before, these are great mocking tools that we can use when we're trying to mock, like I just did with the substitute teacher. Mocktail image network. One of the things I encountered when I was building this presentation was a big struggle with network images. All right, so this is a great tool built by our friend Felix, who that can do a mock wrapper around HTTP requests specifically for images. It'll make our mocking and our testing much easier. And then a fun package called Full Coverage, which is really useful. I started this because of a fun quirk that I'll show you in just a second. So let's talk about that full test coverage package real quick. So one of the fun things in Flutter, in testing specifically, when we run tests, let's go ahead and just run all our tests real quick. I'm going to use a command that I personally made that I'll show you a little bit later.
Could you make it just a little bit bigger?
Yeah.
Just
yeah.
Command plus should make it, yeah. Yeah, that's perfect.
Is that big enough?
Yeah, I think that's
Thank
better.
you. So I have a little make file with a bunch of commands that I'll show you a little bit later. So this is the initial result when I run that make test file. This is an LCOV report that is auto-generated. I have it popping up in my web browser. This shows the coverage I have for each of my files. But if we go back and look at my project, not all these files are listed. At least not all the files I have here are listed here. I don't know if I'd call this a bug, but there is a way to make sure that all the files you have are represented in this report. And that is through this great package called Full Coverage. So what I can do in my make file, I can actually go here. I'm going to uncomment my line that I had where I actually call this Full Coverage package. And if I rerun my tests, now I have a full representation of my full project. So that's a good way to make sure you're testing all the appropriate stuff. You're not missing any files in this case. All right, as you can see, I have a lot of missing coverage here. Not saying that coverage is the only metric you need to use when writing tests, but it's something I strive to do when I write tests. I strive to get 100 to be awesome, 100% coverage would be great, but anything I think above, I don't know, 80 in my opinion is pretty nice. But in simple cases like this, 100 should be doable. So let's see if we can do that today. I think I want to start working through the app and doing some tests. Let's do that. Let's do some live testing. So I'm going to start with some of this UI components. Since we've seen the UI piece, let's start there. So I'm going to go to my UI section. This is my cheat sheet that I've already worked with all this. I'm not a coding or a testing master. Don't worry, I've already worked through this, so bear with me. So this is my main screen. This is the Poke App home screen. I've got my scaffold. I've got a block provider. I've got a block builder. And then I've got this scroll view. Here's my sliver app bar, and then the list of Pokemon below. So a few things that I notice here when I'm thinking about how do I want to efficiently test this. The first thing I notice, starting from the top, is that I've got a block provider and a block builder in the same widget next to each other. This is going to make it really hard when we're trying to mock dependencies and do our dependency injection, right? When I have these two things that provide info to each other so close together. So I think the first thing I'd like to do is separate these into two different widgets. So I'm going to take this, pretty much everything below the block provider. Cut it out. I'm going to put this in a new file. I'm going to call it my Poke App screen. I promise we'll get to testing real soon. Let's pull my imports. Awesome. All right. So now what's really cool is I have my block initialized, or in this case my qubit initialized in a separate section, and now I can just use this Poke detail, or not Poke detail screen, Poke App screen. Hang on one second. This is what I get for naming all my stuff similar names when I made my clean version. Yeah, there we go. Okay. All right, step one. Awesome. So now let's talk about testing that first part, because I think this is really interesting. If I want to test this Poke App portion, I've got a few things I want to look for. So I've got my block provider, which initializes this qubit here, and then I call this this method from the qubit, and I pass in a child of this screen. Pretty easy stuff, but a few things that stick out to me is that anytime I'm initializing a class within another class that has a lot of logic in it, like a qubit, that to me sends a red flag that I want to do some dependency injection here. So let's start with that. So I'm going to give an optional qubit to pass in here. Actually, sorry, the optional Poke list qubit. And actually, what would be even cooler is if I didn't always need to pass in a qubit here. Someone tell me if this is bad practice, but this is something I do. I will do this. I'll put Pokemon list qubit as optional, right? As nullable. But we still have this local Pokemon list qubit that needs to be assigned. So what we can do is we can come after here and assign it to either the one we have passing in a parameter, or if we're not passing in one, we can initialize our own.
We'll have to drop that const in front of the constructor.
Yes, thank you. I knew I was missing something. Good call.
And then the one at the bottom, you're just missing a parenthesis.
Yeah.
Closing parenthesis.
Appreciate it. And now, instead of initializing this here, I can use my local version. Boom. This is already looking much, much better. So now I know that I can pass in a custom qubit or a mox qubit, and I'll have to worry about initializing and worry about the functionality that's inside this real one. So let's try it. Let's actually, in a presentation about testing, let's actually write some tests now. Huh? So if you've never written tests before, there is a lovely folder that you should have called tests. And what I like to do, and what I've seen other people do, is share the same file structure as you do in your library folder in here. So in this case, I've got my UI folder. So I'm going to do the same thing here. I'm going to create my UI folder and then name my test. Similar thing. Okay, app underscore test dot dart. Really important to have that underscore test. That's how Flutter knows you are writing a test file, or else you will get very angry code. Test syntax. Pretty easy. You've actually seen the syntax before if you've written a Flutter app. Well, maybe you haven't. You may have not written it, but it's auto-generated for you at some point. We've got a main function. And then for the test specifically, simply test. Or in our case, we're doing widget tests, not unit tests in this case. So I'm going to start with a test widget template, description, pick your description. I'm going to just verify OK app renders. And then here's that fun little widget tester we get now since we're doing a widget test. All right, testing in general. Let's let me see if I have room to pull up a side by side because that'd be super fun here. Good enough. I'm gonna make some mistakes here. Bear with me. It's all gonna make sense when we finish it. So first thing we want to do.
You might be able to close your file explorer a little bit just so we get a little more room.
Oh, good call.
Yeah.
Is that better?
A little better. Perfect.
Okay.
The top toolbar all the way on the right-hand side, the most icon.
Just click that away. Don't even need the file explorer. Perfect. Done. Okay, for testing, we need to tell the system which widget to show, which widget to test, right? So I'm going to start with that. There's a nice function on our tester, what do we call it here? On our widget tester called pump widget. Pumping mean pumping. And I'm going to put that as my Poke app. So now if I run this, I think I'm going to get a lot of angry things. Let's just try real quick. Yeah, a lot of stuff. So this is probably the most common error I see when people start out with testing. When you are pumping a widget, you need to make sure that you've got a couple things surrounding your widget. Number one, you need an app. In this case, I'm going to use material app. And number two, you need some sort of material widget. So you can either use material proper, or a lot of people like to use scaffold. Body of your widget. And I'll show you some ways earlier that we can streamline this, but for presentation's sake, this is how we'll do it. So now if I run this, we should be happy, minus my one issue somewhere. Except, of course, now I'm missing my block provider. All right, so here's where the dependency injection comes in handy. Like the substitute teacher analogy, I don't need to put in my full Pokemon list qubit, right? We don't need the full blown thing in there. I should create a mock, or a substitute in this case. So to do that, I can do something similar to what I did earlier. I can do a mock Pokemon list qubit. Thank you, autocomplete. Yeah, this is good stuff. And in this case, I'm going to be using the tool we talked about earlier, the packaged mocktail. Tell me with my mocks. So mocktail under the hood. Let me show you what mock is. It's a lot of cool stuff under here. This is going to help us stub and mock all of our calls that we need to use. If you're familiar with some other programming languages, I think some other languages use Mockito, right? A similar tool. Okay. So what I need to do in this case is I'm going to initialize a instance of my mock qubit. I'm going to do it late. We'll see why in a minute. There's a really handy tool, or handy method called setup, which runs before each test. So I'm going to use this method to initialize my qubit. And now I can pass that qubit into my widget. Yes, awesome. I'm going to try running this again. It's still going to fail. We'll talk about it in a second. Let's see if it gives us a good reason why. Could not find. Oh, okay. It's because I mocked badly. This should actually be a mock block using the mock block package, not the mock tail package. That's my bad. So block test, another great package made by our friends that helps us mock blocks and qubits. In this case, syntax is mock block, whatever state that the Pokemon list qubit is using, which in this case, actually, wait, do I have a mock qubit?
I think you do.
Is there a mock qubit? Yes, there's a mock qubit, where I don't need events, I just need states. So mock qubit, and then I have my Pokemon list view model that I can pass as my state, official state. All right, forget about mocktail, we'll get to mocktail later. Back on the mock qubit train. All right, now let's try running and see what we get. It says it still can't find the correct block list provider. Probably because all right, what am I missing in this case, team? What am I doing wrong, y'all?
Randall said maybe check what that one problem is in case there's something.
That's right. I think it's just a constant. Oh, was that actually it? Oh, maybe that was it, Randall. Good call, bud. If all else fails out, my cheat sheet here. We'll look and see. I did this earlier.
It may also be that you have to specify the types. Actually, yes, it is. I've ran into this.
Isn't it? Yeah. So can I think I can actually register this as a just
Yes.
Pokemon list qubit
Yeah,
instead of a mock qubit.
and that should work.
And now we should be on fire.
Same error.
Same error in this case. Let me see what I did earlier real quick, y'all. See what I'm missing here.
You may also have to specify the specific types on the block builder and provide
Yeah.
it itself.
I thought about that, but it should still work regardless. Okay, let's try that. This is a live presentation, right? So let's take advantage of it. So what they're saying is maybe for like
Yeah, I would put it there and then also on
Here.
the block builder and
you have to
the Poke-
specify which qubit to use. So let's get this is a Pokemon list qubit. And let's try that first and see if that gets it. Okay. Bear with me a second. All right, Steve, any other ideas? What am I missing here? This is the fun of testing.
I may also add it on the block builder and the Poke App screen. Make sure that those are. So if you like go into the Poke App screen on the block, oh, it's already there.
Yeah, right, got it here.
Oh, but it's importing the clean in this file.
Ah, that's what it is. All right, this is what I get again for using similar language in both, huh? Good call. All right. Hey, that's better. Okay. All right, now we're on to our next issue. So now we need to figure out what parts of our block, our qubit in this case, we need to stop. So in our case, there's one that usually gets called, which is the qubit state. So I should be able to do something like when my mock Pokemon qubit.state is called. I'm going to tell it what state I want it to return. In this case, I'm just going to return just a basic empty view model. Make that constant. All right, let's give it a shot and see what happens there. Boom! Yay! We have our first passing test. But we're not actually testing anything in this case, right? We just have a green light. So let's test some stuff. Here's what we do. In this case, I want to do some UI tests, make sure I'm rendering correctly. So if I go to my widget, I can look for a couple things. Since I'm returning a state that's not loading. That means I'm not going to enter in here. So that means I'm actually going to get this result. So there's a few things I can look for. I can look for, or in this case, expect, which is our keyword for how we validate testing. There's lots of different types you can use for your matchers in this case. So, or not for your matchers, for your expected tests, your actuals, I guess. In this case, I'm going to look for a specific widget. So I'm going to say expect find by widget type, by type. And I can actually look for specific types of widgets. So in this case, I'm just going to pick a bunch of the widgets that I'm rendering here and go through the list. And I want to tell it, I'm telling it to find a custom scroll view. I'm going to tell it what to do with that. I'm going to compare it to finds one widget, since I'm only returning one custom scroll view. Let's do that quick run just to validate. All right, next error. I'm missing my await and my pump widget. Yes, thank you. Thank you, Flutter, for reminding me. All right, that's a success. So we did find that custom scroll view. Let's try a couple other widgets just to make sure we're rendering the correct thing. So I can also search for my sliver app bar, make sure it's rendered correctly, or make sure it's rendered. And I can do the same for my sliver list, but I think my sliver list might fail since I'm passing an empty list. Let's see what happens. Let's do it without the sliver list first. Boom. And let's do it with the sliver list. I think we'll get a fail. Excellent, we did. All right, this is good. Now we're on track. So why did it fail? Because the sliver list is not going to render if I'm passing in an empty list. Pretty sure that's correct. Someone correct me if that's not the reason that's not rendering, but pretty confident that's right. So now that's it. Now, so there's a bunch of other code down here where I'm rendering each of these list tiles that has the Pokemon information on it. But I'm thinking this might be a good chance for another refactoring, because I don't want to have to go through and test that it renders every single one of these. I should be able to test the list tile maybe in its own test, its own UI test. So I'm going to do a quick bit of refactoring again. I'm going to return a Pokemon entry tile. I'm going to go create that Pokemon entry tile. course, I gotta pass in my Pokemon parameter. And there we go. Of course, I gotta import my new entry tile.
You'll want to return that. Yeah.
Oh, I got it. Thanks, man.
Just
All right.
making sure.
So now, in this case, I don't really want to worry too much about this. I do want to make sure I do get this sliverless back, so I'm going to duplicate this test. Don't hate me, y'all. I know there's room for refactoring here and consolidating code, but we're in a presentation. I'm going to validate Pokemon list. Let's see if I can get a mock Pokemon real quick. We want the URL here. This is actually called something else. Is it just URL? Perfect. But it needs a URI. All right, I'm going to ask a question later. I want to know what people are doing with URIs recently because I haven't used the HTTP package in a while, and it is frustrating the crap out of me using URIs instead of strings. So, okay. So in this case, we're doing the same test, but instead, whenever we call our state from our qubit, instead of returning just empty list, we're going to at least return one Pokemon so that we can render the sliver list. So in this case, we should get our sliver list back, and at least one Pokemon entry tile. And I'm just going to do another fun find, just as an example, even though there should only be one, just to show you guys some additional options for this. All right, here comes our first big fun workaround. So, if you guys remember a little bit earlier, I talked about a fun package called Mocktail Image Network. Here's where it comes in handy. So in this case, we're using the HTTP package. It doesn't play nice with testing. Thankfully, Felix has written us a very nice package where we can wrap some magic. So in this case, I'm going to wrap my pump widget in something called mock network images. Again, this is from the Mocktail image network package. I did not write this. Make sure I'm getting the syntax correctly here. And this needs to be asynchronous. I close it out. So I'm pretty sure this just bypasses all the HTTP requests. You guys can go dig through the code. It's really interesting. So when I run this, now, shouldn't care that I have my network images, provides the mocks for me, and I get a green arrow, green check mark, that we are seeing all of these widgets. Good job, y'all. We're at our first test. There's actually still one thing we're missing. It's our loading state. And I have some other fun errors to show you in this one too. So we're going to do the same thing. I'm going to copy that first test and verify Flutter App renders loading state. I'm going to update my loading state to be true for my qubit response. And when I run this, I should see what do I have? Circular progress indicator. Famous Android circular progress indicator. see what happens right off the bat. We get a success. Okay, here's what usually happens. A lot of people will do something called await widget tester.pump after, I'm sorry, await widget tester.pump and settle. And this is good for when you have like animations and stuff that need to finish rendering before you start testing your UI. So if I were to actually add this and wait for everything to resolve, I should get an error. And I'll explain why in a second if it fails. It does. So pump and settle timed out. This means that there's something still happening on the screen, some kind of usually animation that's still occurring. In this case, I have my circular progress indicator that's constantly going. So Flutter's smart enough to say, hey, there's still something happening. You need to either stop it or I'm just going to time out. In this case, it times out. So if you come into that and you do have animations, a few things you can do. There's the option to pump a certain duration. You can pick however long your animation is, 500 milliseconds or seconds. Your test will not take that long, but it will speed the process. Test it for you. And we're good to go there. Make sense? All right, we've got all our scenarios set. I would say this is fully tested. We can check now. Let me get rid of all my unused imports. We run our test again. We pop up our little, oh no, we have a test failing now. What's failing now? Verify Poke App renders. What did we do? What did we change? All right, I added this because it was failing, right? I added that sliver list to show you guys that it would fail, and I forgot to put it back. We're good, we're good, it's gone. All right, so now, I would like to show me that I'm fully covered, which it does. This is done folder by folder, so bear with me. So if we go into our, and then I've got nested stuff here. Hang on one second. Live UI. Aha, here we go. And here's our Poke App screen. 100% code coverage. We can actually dig in and see all the lines that were run during tests, how many times they were run. Super helpful tool here. Again, I'll show you guys how to do this really easily at the end too. Cool. All right, that took a while. We're probably going to skip the rest of the UI. We're going to move to some other fun stuff so we can get a little bit of variety here. I do want to look at the models that I'm using here real quick, the data models. So for example, let's look at the Pokemon details model. So this is the model I'm using for the detail screen. Nope. Where'd my app go? There you are. For the detail screen here, when I click into one of these. A few things here. First thing, there's a lot of code here. I've got, obviously the code to initialize the class. I've got from JSON. I think I deleted all the 2 JSONs or else I'd have a bunch of those here. That's a lot going on. This would be a great opportunity to use code generators, right? So there's a package you've probably heard of. There's actually 2 packages. We're going to use one of them. The one I want to talk about is Freezed. You guys might have also heard of JSON serializable. I do like Freeze because you also get quality out of the box with Freeze. Super helpful. And Build Runner is the package we use to generate all our generation files. And then I talked about Mockito a little bit earlier. If we have time, we'll break into that a little bit too. So let's talk about Freeze. So Freeze, along with JSON serializable, is going to help us reduce this code significantly, where we are able to do some more minimal testing. You can go read the Freeze documentation and learn how to convert what you call like a more normal class into a freezed syntax. But what I like to do is use some fun tools like our friend Copilot to do this. So let's see if he'll do it today. He was working yesterday. So if I just highlight this whole thing, I'm using my AI copilot to say, please convert these classes to freeze classes and include a from JSON.
You know you don't have to be polite to the AI.
I know. You guys better watch out. You're laughing now, but when they take over and they're like, Cardin, you were so nice to us, thank you so much, you're going to be not laughing. All right, so let's see how it did. It usually does pretty good. It looks like things went really well. The reason we're seeing errors is because I haven't run build runner yet to generate these auto-generated files. But first look, I think it did pretty good. And that just saved me a lot of time trying to manually convert these, because there's like at least 6 classes in here that I would have had to convert. So let's try it. So to use our build runner, I have a fun, quick version. I just say make it pretty, and it does a bunch of stuff. So I'm gonna run that, and let's see what happens. Boom. I don't see any errors. I don't see any issues. I think we're good. So that's one quick way to use some of your auto-generated packages to help you streamline some of your work. And now, for me to test this, pretty straightforward. If I really want to, I'd give it just a basic JSON that I could run through and just verify that it spits out the correct one. That's more for my sanity. And obviously, anything that is put in here, in theory, should be converted correctly by the package. No. Thank you, auto-generation. Love it. What else can we talk about? Let's look at the qubit itself, one of the qubits. This one specifically. So I'm going to close out these other windows real quick so we can get a full view. So this is our list qubit. This is the one that brings up the main screen. This guy. And let's see if we can refactor this one similarly to how we did the UI portion, and then write tests for it. So first thing I see here that stands out similarly to our qubit in our UI is we've got our Poke service initialized here. This looks like a good opportunity for dependency injection again. So I'm going to go ahead and do that. Same syntax I did earlier, where I've got my Poke service. And then I can initialize it below if I don't pass in a value. Boom, same thing. And then I get to replace my instances of Poke service. My injection. Super easy, right? Love that. I mentioned earlier, as you saw when I did the mocking for the qubit in the UI, there's a package called mock. Is it mock block? That's how they say it, mock block. And I can use that to help me mock this, or no, sorry, test block. I can use that to help me test this block and all the functionality in it. Streamlines a lot of the testing you would have to write if you didn't use it. So let's take a look at what that looks like. I'm going to go back to my test file. I'm going to create my new block folder. And I'm going to do, you guys remember the syntax? Pokemon list, qubit, don't forget the underscore, test, dart. And then with any test, we always start with void main. And then we can start writing tests. We got our entry point. And instead of doing our test widget, or test, just normal unit test, we can do test block. And it gives us a bunch of stuff we can play around with. So first thing, we obviously want to initialize the block we're working with. In this case, our qubit. How's that view? Can you guys see it okay? Cool. In this case, our qubit. And it gives us an act option, which then we can use to call our action. For example, we're going to call get Pokemon list because that's the method we're testing here. And then what we expect from the block once we run that action. A few things we can do as well that I want to show you that aren't applicable to this qubit specifically. You could seed a state. So if I want to start at, well, in this case, like when I initialize this block, initialize it in the loading state, say I want to start this test, I already have information, I can go ahead and seed it with an existing view model or a different state. So that's really handy when you're doing more complex tests. Let's get back to ours. So for us, once we initialize and we call our action, we call our block get Pokemon list, we expect it to obviously get our list of Pokemon, and then we're going to emit our view model with our list. So you probably already guessed, we're going to need some mocking here because we don't have a POCA service, or if we do, it's going to actually do our real POCA service. We don't want that because we don't need it. We want a substitute. Let's go ahead and do our expect before we dive into that, because that's going to be a little more complex. So I do at the end want to expect that it emits this, a Pokemon list of view model. Make sure I'm doing that right. No, I'm missing something. Hang on. I do expect. I thought I got a list. Hang on, am I missing something here? Let me look at my cheat sheet real quick because I'm not. Well, actually, hang on. Before I get to that, let's go ahead and mock the dependency before I get to that. So I can do something similar to what I did earlier, where I mocked my qubit, but instead of using the qubit mocker, I can do use mocktail, like we talked about earlier. Same syntax. I can do my mock Pokemon, or what do I call it? POCA service. Extends mock, implements the actual POCA service. Using our good friend mocktail. And once I have that, I'm going to do the same thing I did earlier. I'm going to initialize it in my test setup method. And now I can pass it into my qubit. Sweet. The last thing I am really missing is I need to say what I want to mock, or like what I want it to return whenever I call the get Pokemon method. So to do that, test block also comes with a nice setup parameter you can use. Man, thank you, Copilot. Just killing it today. So same syntax we did for mocking earlier. Whenever my mock service is called get Pokemon, then I can answer whatever I want. In this case, I want a future empty list, or I could do an actual list. I think, so there's two options for to answer. You can do then, return, and then answer. One of these is preference for futures. Let me double check which one that is, because now I'm curious. And it doesn't tell us in the mocktail documents. It definitely does in the mockito documents. use that answer for asynchronous, so that's fine. We are good. Okay, now we got to figure out what to expect. So whenever we run a block or a qubit, we obviously expect a stream coming out. This is no different. We are expecting a stream, and we can do a list of results. In this case, I'm getting my, like here on line 13, I'm getting my Pokemon list view model with an empty PokeList. I got all my braces correct. There we go. Okay, I think we're good. Let's give this a shot and see. Something does look wrong though, because I'm not getting a run symbol here, so I'm curious what I missed, if I missed anything. Am I not in the test folder? What's going on here? You guys see what I'm saying? I'm not able to run this test.
If you run it from the command line, does it show up as a test?
Maybe.
Sometimes I think VS Code just gets out of sync.
Is it angry? Okay. I really don't want to run it from the command line. Let's see what's going on. Anybody out there see my mistake? If you do, let me know. All right, well, this is why I bring backups. So let me go to my sample test and see what I did wrong.
Doesn't look like it's showing there either. Maybe the run button just doesn't support the...
This one's a little bit different because this is not in the test folder. So let me bump this up to the test folder and see what we get. Yeah, that one's fine.
These are in groups, but I don't think that would make a big difference.
Sure. All right. Well, I'll post the clean one later. But the syntax is the same in my example here. So once we add all that and we run, we get all greens. All right. So that's one scenario. Since that's the only method I have in this block, or in this qubit, sorry, that's all I need to test. It should have 100% coverage there. For the view model that I'm using in replacement for my state, pretty easy here. I just have a factory method, but I'm almost using equatable instead of freezed here. So there'd actually be two things I want to test. So one, to make sure that my factory returns what I expect it to do. And then you're also going to want to test your equatability here. Super easy. You can do it a couple ways. You can, well, we can do it real quick. Actually, did I already do it here? I already did it here. Just to show you, because I don't want to spend too much time on this. If you instantiate a version of the model, and for equality, you can either, I guess, create two versions of the same model. So we could do this two ways. We could do Pokemon list view model 1, Pokemon list view model 2, with the same parameters in here. Just realized I missed its loading here. The same parameters here. So even though these are two different instances of the same class, they should be equal. All right, now I'm really testing my testing chops. I thought there was a equal, there it is, equals matcher. I kept wanting to say is equals. So verifying equality, good. So even though these are two different instances of the same class, they're still equal because our lovely equatable package is doing all the heavy lifting for our equality here. Or you can compare the props. So that's what I was doing originally. I was making sure that my equatable props were proper. So in this case, it would return my list and my loading state. I should get the same answer here. This is what I get for going off presentation. What am I missing here? Oh, I didn't do equals, right? Equals. Duh. Nope, still doesn't. Expected, false, actual is this. All right, again, that's what I get for going after else. Don't do that one. Do this one. Do this original one. This one's much better. See if the two ones are actually equal or not. I like that version better anyways. Makes more sense. Okay. We are getting low on time. Let me think if there's anything else I want to go through. Did code generation. Did our freeze package. I do have some other fun tips and tricks just to close out on. So you might be saying to yourself, this is all great and dandy, but I have an existing project. I'm already knees deep in code. It's been out for a few years. I don't even know where to begin testing or how to start. Something we do at my job is we use a package called pull request coverage. So if you use Git to track your project, using this package, you can start checking code coverage beginning with your next commit. And it will only check new code or edited code from previous commit to current commit. Super helpful. So that means you can start testing your new code and not have to currently worry about your old code. And then as you go, as we know through code rot, eventually you'll have to touch your old code at some point, right? Then it'll flag that code, your old code, whenever you edit it in the future, forcing you to then write tests for that. So it's a nice way to keep yourself accountable, but not go crazy over writing tests for an entire existing project. The other one I'm going to talk about is the makefile I mentioned earlier that I used a couple times during this presentation. This is a custom one that I do have linked in this presentation if you want to download it or check it out via GitHub. This is just a list of really what usually takes a long time to type in the terminal. Some great quick versions to run commands. My favorite again is this make pretty command that runs pubget, does your build runner, and then formats the code to my specifications, which I love. Same thing with testing. That's what I'm doing when I'm doing my make test, where it runs code coverage, it validates all the tests, it runs lcoff, and it pops it up where I can view my report in the screen. A few other sources that are really fun. I've got listed at the end. You can go check this out later. Last thing I do want to show you before I officially end the presentation. I had to do a lot of research for this presentation. By research, I mean looking at other people's code to see how they test, because I wanted to get a good variety of opinions. One of the best ones I found was something that our friends at Very Good Ventures did with the Flutter team that helps mitigate some of the code we have to make when we write tests. So if you go back to our original widget tests that we wrote, you guys remember all this stuff we had to write? This doesn't seem like a lot, but when you're doing a full-scale app and you have localizations, you have navigator observers, all that stuff you need to pass in, or you have repository providers you need to worry about from a top level. This can get really, really big and heavy. And one thing I love that they've done is this example in their news toolkit package. Is that big enough? I'm gonna see if I can make this bigger. Hang on. Yeah. And if I scroll down to where they have this custom extension that they've made on the widget tester. Do you guys remember widget tester? That little extra parameter we get when we do widget tests. They've got this amazing pump app method that you can call, and it does a lot of this cool stuff. Hang on, let me go down to it. So they have all their block providers up on top. Here's their material app that they're initializing. Theme initialization, putting in navigation observers, and then at the bottom, they do their pump and their jobs here somewhere. Yeah, here, underneath their scaffold. So if we had this, instead of doing pump widget and having all this extra crap, we could just do pump app. And like that. Obviously it's not gonna work because I don't have the pump app, but saves a lot of code, especially when you get these big projects. Super helpful. I showed this to my team at work today. They loved it. We already implemented it. So thank you, Very Good Ventures and Flutter team, for building that. Really, really happy to find quick tricks like this to help out.
If you ever spin up a new project with their CLI, it'll come with this as well.
Does it really?
Yeah.
Ah, that's awesome. Good to know. Good to know. Okay. Again, feel free to check out the extra resources at the end, and I will open it up to any questions.
Ross had a question. He said he's a solo dev. Most of his time writing tests is building and maintaining his integration tests. Do you think that the unit and widget tests have good value for him as a solo developer?
I think so. So my team, we do very little integration testing just because of the amount of work it takes to create them. Most of our tests come from widgets and unit testing. I don't know. What do you guys think? You guys do some too. That's my opinion.
Yeah, I think, Ross, you actually probably started at the harder end of things. I'd have to see how you have it set up. Maybe it did make sense for how you set it up, but I would actually say building and maintaining integration tests is typically harder and more time consuming than building and maintaining the unit or widget tests.
Yeah.
I would think.
Agreed. Good question. You may have to come do a presentation on integration testing then, Ross.
Yeah, that would be awesome.
Any other questions in the chat?
Not so far. Do you have any questions?
Okay. Awesome. Well, thank you guys for listening. Thank you, Black Airplane, for hosting. And we'll see you guys at the next meeting.
Great job, Cardin. I can remotely end it from here, so bye guys. See you next time.